If folks have questions for Jeanette or Jim, please either raise your hand and I'll call on you, or you can type it into the chat if you're more comfortable with that. Um, I did see that there was an earlier chat question for Jim, and I think he already addressed it. But Jim, did you want to say any of that live?
I'll just say, the question was about how Mars landing site selection is different from Artemis. And like I wrote in the chat, it's a totally different beast. I mean, from a Mars rover mission, we'll pick a site, spending years to deliberating it, but the site is picked, and that's where we're going. I mean, once you launch in that window to Mars, you're going to that site. There's no two ways about it. You're going right in. Artemis is going to be very different. I mean, things that we've all talked about the last 2 days is, the launch, the lighting is a big deal that Mars we don't have to deal with, because on Mars, we're landing in equatorial areas. It's more like Apollo landings. But Apollo was different because you have these 2-week-long night periods. On Mars, we have pretty much a normal cycle like on Earth. It's a little bit longer, 40 minutes. But yeah, and we don't have backup sites. Once we pick a site for Mars, that's where we're going. In the story, it's over once we're deliberated that. So there are no backup sites. That's where we go. But this is going to be so different, and it's very exciting. A lot more. It's going to be very complex in different ways. People have already talked about all the data sets out there. I've noticed that for Mars, when we first worked on Mars Pathfinder, we had Viking data in the story. That's all we had. And as we progressed through Polar Lander and Spirit and Opportunity, and then on and on, Curiosity, all the way to Perseverance, you have layers and layers of it's useful, great data, but it's a lot bigger task to do. But it's critical because it helps you really get down to it. But the thing here, the illumination to me is just something, like I asked earlier this morning, is if you miss a launch window, or you're on the pad and you have a couple scrubs, what is that going to do to your site? It depends on how many scrubs are, and say you're even in lunar orbit. The way I understand it for the landing is your lunar orbit is a 6.5 days, and if you're up there getting ready for your powered descent to go to surface, you have a computer problem or whatever it is, and you can't get down then. Do you have to wait that 6.5 days orbit to get back there to go back down? There's things I'm not clear about the mission profile. And if so, in 6.5 days, your lighting is going to be very different. So those are things to me that I don't know the answers. I'm sure somebody out there is working on it, I hope, because we're going to need those details. These are things on Mars we never have to worry about. So there's other things on Mars we have to worry about, not on the moon, but it's different, but it makes it exciting and interesting.
All right, thanks. Let's see. I see a hand raised. Eliane Lee.
Hi. Yeah, I just have a question for Jim. Hearing you discuss some of the insight you have from your Mars missions, and you also mentioned the importance of having a lunar rover to assist in surface operations for astronauts. What have you learned from the Mars rovers that could potentially be applied here to improve previous designs of the lunar rovers?
Well, I'll say something about this briefly, but I'll let Jack talk because this guy's done it, okay? He was on the moon using a lunar rover, and he's been there doing as geologist. So the Mars rovers, early on in the Mars program, there was a debate before Pathfinder, definitely before Spirit and Opportunity landed. We don't need rovers. We can put a stationary lander out, reach out, grab a sample, return it. We get everything we want. That discussion is gone. It's so ridiculous. We used to have almost knockdown dragouts about that. Mobility is crucial if you want to do science, and you have to have it. And I don't think there's anybody in the Mars community who would ever argue about not having a rover. I mean, now there's different things like the Mars InSight lander was a seismic geophysics instrument you put down on the surface and stayed there. It depends on the science objectives, but especially for exploration, you want a rover is critical. And Perseverance and Curiosity, the thing about those, they're RTGs, and we don't have to worry about the sun. Like Spirit and Opportunity, when dust storm come through there, we had to hunker down. It's so much fun working on Perseverance. Dust storm comes, we don't care. We just keep on working. But I know that there's a competition out there now for the Lunar Terrain Vehicle for NASA, and several companies, Lockheed, I know I'm kind of involved with them, putting one in with General Motors. I think Jack is on one of the teams. There's a lot of people out there, and but I'll let Jack talk more about the rover because I mean he's actually done it, not me.
Well, I think the roving vehicle of some kind is essential for good science, field science. The I have nothing but compliments for those people that designed and produced the LRV. It worked very well. The one thing that we added to the early plans was a sampling device so you could sample every once in a while along a rover track. With the moon, that's important because the regolith changes subtly with distance, and the contacts are not obvious. Believe me, the and so having the crew with that kind of a sampling device, or maybe it could be automated. Either way, I think is important. But rover traversing is something that I think is in the mix indefinitely. The one thing that I would do is reevaluate the walk back distance. I think we were overly conservative on Apollo. That was walk backs. Really, you could go about 7 kilometers and then have about an hour and a half to work, and then you'd have to start back. I think you could increase that at least to 10 kilometers, if not more. But it takes crew buy-in to learn a new technique for walk back. Actually, cross-country skiing technique, I think, is the best technique to do. It's very efficient and it's very fast. And so that can extend your walk back distance significantly. But that you have to remember that in your rover related planning is that operationally you can't go on indefinitely. You have to be thinking about what if the rover fails, and how do I get back to base camp? Now, our LRV, I don't think could fail in any significant way. There was redundant steering, redundant drive wheels. You could lift the thing out of anything that would cause a problem, such as getting stuck, as they said. Now the LTV is going to be much heavier, and I don't know right now whether that is going to lifting it out of the difficulty is going to be reasonably feasible for two crew. We'll just have to wait and see how it finally develops.
I mean, one this is a perfect world, which is probably not going to happen. We all know. But if we had this rover down there before the crew got there, this rover could do recon of the whole the area, could even possibly bring back samples for the crew to, triage through. Of course, the crew's still going to go out there and do stuff because people are just better explorers than machines. But if the rover is down there, it could map the area and kind of highlight places for the crew to zero in on. But that's a big if that's going to happen.
Well, precursor rovers, I think, are really a good idea. They help to evaluate the plan that you have for a site and make everything more efficient. It doesn't cut out the field geologist, but it certainly will make the work much more efficient. That I think is an important consideration and a good idea, Jim.
I also think it's interesting, considering some of the discussion about lighting, to consider the role that remote sensing instruments mounted on rovers could play in counteracting some of the difficulty within geological sampling. If there's a possibility to have real-time spectroscopy or thermal imagery, and I've heard discussion as well about the potential of an Artemis science backroom, which would be complementary to the mission control system.
Yeah, clearly the LTV development should include the capability to have such kind of sensors and to get that information to such a backroom for analysis. It can help, particularly longer duration missions. It can help in the planning of future EVAs. Also, having a post-cursor capability would be important. If I have the time, I'll tell you a very quick one. After I discovered the orange soil volcanic ash at Shorty Crater, I know there was a great deal of debate in the science back room about changing the third EVA to go back to Shorty Crater. We had a good sampling experience at Shorty Crater, and even though we only had 30 minutes of time there, I was pretty certain the backroom would finally decide, hey, forget it. We don't know what we're going to learn on the third EVA, and you always have to keep that in mind. What's the opportunity cost of having information? On the other hand, if you had a post-cursor rover, then you could go back to to a site of interest and gather more information. Having really a variety of capabilities in your roving is I think going to be very important in the future, and also the idea of landing the rover early, I think, is already in the mix, and it certainly would be in the mix in a Mars expedition, because you would want to have the rover there in order to come and pick up the crew.
All right, thanks. I'd just like to break in here and give Jeanette a chance to answer some questions as well about geologic mapping. Um, so I see in the chat that there are some questions about how the geologic mapping was being done and what are some best practices maybe, and any other tips you can give folks.
Yeah, thanks for that question. So, yes, everything that we did was done in ArcGIS Pro, and there are some planetary geologic mapping tutorials. So if you want to email me, I'm happy to send you some links to those. It's jluna@tntech.edu. And it's really fantastic now because we can manage all of our spatial data kind of in one place. And so we use kind of a combination of ArcGIS Pro, and then of course we all love Quick Map as well. So thanks.
Yeah, I didn't catch if there were any more questions for you in the chat, but you did kind of leave like a nice little breadcrumb about the upcoming LSSW. Um, is there anything that you recommend that be on the agenda at that meeting?
Yes, yes. So I think it needs to be, well, of course, I talked about nested mapping, so you know what I'm going to say. It needs to be a combination of maps for context, right? We need to understand the context of wherever we map, and then also going all the way down to the scale of traversing. So maps in specific landing regions, oversights with traverse, kind of thinking toward a traverse and how you could do that in that 2 kilometer radius. And that's a huge scale jump, right? To go from kind of global all the way down. So I'm really hoping that as people put in abstracts, we can kind of see a variety of scales and not focus just on traversing and not focus just on the global context. That's what I'm hoping for.
Yeah, and maybe one follow-up question too. I know that workshop is largely geared for geologic mapping, but maybe like what about other kinds of maps that we might need to either train for these surface activities, like astronaut training, or even for just like science analysis, if there's things that we need prior to the mission.
Yeah, there's all of the, I guess, we've been talking about them as tactical maps, right? So thinking about slopes, traverses. So there's the kind of bucket of tactical maps for the practical applied science of it. And then there's the scientific mapping, which is kind of the standard geologic mapping. I think it would also be very useful to see terrestrial analog samples. So if astronauts are going out at this point, I know there's mapping that's associated with that, both with DRATs and JET and other terrestrial analog just activities that are happening. So I think seeing examples of those maps, and in particular how those maps are being, what they're finding useful and what they recommend, right? Because there's outcomes from that of, oh, this map it's too busy, it's got too much stuff, it wasn't possible, for us to find it, or it wasn't as useful as we think we could have found it. I think one of the things that Senator Schmidt said earlier that I found really helpful was the fact that you can't really see a contact that we may see very well from orbit, you can't really see very well on the ground. And so then that begs the question of, if you want to sample 2 units, say you've got a contact, you've got a unit on either side, how far do we think we need to go into those units? Is it, try to walk 10 meters away from where we think this line is, or do we walk, 20 meters, or, how are we going to approach sampling different units when we know that those contacts are going to be really, I don't want to say muddy. They're going to be very dusty on the ground. And I see Senator Schmidt has popped back on, so I'd love to hear.
I
Love
would
to
just
pass it off to
say, I'd
him.
just tell you, that's the function of how long that contact's been exposed to meteor and micrometeorite impact. In the case of the contact between the light mantle and the basalt regolith, actually it was really quite extensive over probably about 150 million years. The spread of that contact was significant. One sample I took in an avalanche deposit that probably is about 150 million years old is 60% basalt and only about 30 or 40% light mantle. So you can see how it gets diffused very geologically speaking very quickly.
A question I have about these regions, you have to have a box or some kind of boundary to show where it goes, but, can you stray out of those regions if there's something very interesting, for instance? I mean, can you go in and come back out, along these, it's typical, a map. Interesting things always happen at the edges of it, quadrangle mapping, whatever you're doing. And I'm just wondering how strict these boundaries are. I'm sure I understand you had to have something there to kind of put it down there, but as we start delving down deeper and deeper and starting putting down 2-kilometer footprints and doing traverses, how much leeway is there in some of this stuff? And I'm imagining it's probably a decent amount still there.
Anyone from ATO want to tackle that before our break?
Well, Jim, that's a good question. I mean, I would the way I would describe the situation is that the regions were all very carefully selected based on iterations with our prime contractor to reflect various hardware requirements. So it's probably important to separate the physical act of landing, the dynamics of the touchdown, navigation to a safe landing, and then what comes next, exploration, utilization of the surface. So I think there is a natural tendency to mix those two because we'll be using the same data sets for both of those purposes. But there is a difference between the physical act of touchdown and how you safely navigate to the surface, because ultimately that is the objective here, right? We don't get a safe landing, then we can't do any of the wonderful stuff we have to do.
Yeah, safety trumps everything, exactly.
Yeah, absolutely. The safety of the crew is our highest priority. So once you get through that gate, then you get into a position of being able to do interesting things. For the purposes of this discussion, for Artemis 3, I don't think we'll be getting outside of the regions, since we don't necessarily have a rover on the first mission, and so it is very similar to Apollo 11 in the pantheon of let's demonstrate we can safely reestablish this capability that we as a nation haven't had for 6 decades. So that it's also important to have realistic expectations coming in. But having said all that, yes, I think it's there are scenarios I could see us going outside of the regions, but the regions are very focused on the safe landing aspects, and not necessarily on the comes after. Does that answer your question, Jim?
Yeah, another question, and I'm imagining you're probably going to say something at the wrap up today, so you can save it for that. But I'm wondering what the next steps are, because I'm hoping this is going to be a kind of a regular cadence, having these things and drilling down deeper and deeper to get to sites. But I guess you're probably going to address that later, so you don't have to answer it now.
No, it's a big question. I don't want anyone, like I was pretty clear this morning. Hopefully, we're not picking a landing site today. This is the start of the process, but it is anticipated, that we'll have similar efforts for Artemis 4. Artemis 5.
Well, I mean,
the program doesn't end with Artemis 3.
No, I got all that, but I'm just wondering, for Artemis 3 landing site, there's going to be follow-up workshops. I'm hoping that this continues. This process goes until the mission is ready to go. But well, not before that. But, there's gonna be more Artemis 3 landing site workshops, correct?
As we have it nominally planned right now, yes, there'll be at least one more, hopefully Artemis 3 focused landing, community engagement landing workshop at some point as the architecture comes into sharper focus. And that's my guess would be that would be next year.
Okay, thanks.
Yeah, no problem. It's a good question.
All right. And on that note, it's time for a little break before we get into the last session about Malapert. So thanks everyone for your discussion and participation, and thanks very much to the speakers too.